Hi learners, welcome to the today's topic. Our today's topic is decision tree induction that is having the important factors. So what are the important factors there? We will talk about that. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So we will see today about how the decision tree is going to work, how it is going to work. Now we will see how we are going to build the decision tree, and then we will see how the decision tree induction for machine learning that is having the ID3. So for that we will discuss about what is the ID3 induction tree model. So then we will go into the how to select attribute for creating a tree. So now we will discuss about these of the all terms. Let us start. So how decision tree works? So first, as we know, a training set that is having the records, that is having the known records. So that will be the known class levels. So for that we have to provide the training set, while the model is going to predict about the unknown class levels. That training set is going to use to build a classification model basically, so which is subsequently applied to the test set that will be applied onto the test set, that is unknown class levels, and which is consist of records that is having the unknown class levels. So for that, the evaluation of the performance will be occur of a classification model that will be based onto the count of test record. How many counts of test records are correctly classified and how many are incorrectly classified. So and then incorrectly classified by the model. So we are going to that we are going to measure, we are going to evaluate that performance on the basis of the correctly classified class levels and incorrectly classified class levels that is predicted by that same model. So these of the counts will be tabulated in the form of that is known as a confusion matrix. So the table will be there that is having the incorrected class levels, and there will be the correctly classified class levels. So that is called as a confusion matrix. So in this table we can see how the confusion matrix will be there for a binary classification problem. So that is basically in this that is having the predicted classes here, that is having the actual classes there in the left hand side. So in the right hand side, the predicted classes that is having the class 1 and 0, that is having the binary classifiers, and actual classes are also having the classes 1 and 0, that is the binary. So here the all the terms is having the unknown and known classifiers. So that was the based on the classified by the model. So that is the confusion matrix for the two class labels. So that is if we are having the problem of two classes, the same type of confusion matrix will be there. So suppose F11 will be there, F01 will be there, F10 and F100. So we will see one by one what is that terms is all about. So each of the entry of Fij in this table denotes the number of records from class I as well as predicted class, predefined class, that is class J. So that is having the class J, that is having the class I. So Fij is nothing but that is having the particular value in the table that is denoting the number of records that is predicted by the both of the classes there, I and J. So for example, F01 is the number of records from class 0 that is incorrectly predicted by the class 01, that is having the class 01. So like this, right? So by that is having the F01, that is basically from the actual class, and that is predicting the class 1. So that is having the F01 term. So based on these of the entries of the confusion matrix, what I have told you for one instance, so the total number of corrected predictions will be there, that will be made by the model. So that will be the combination of the sum of the predictions. So that will be the F11 and F100. That was F00. So that was in the figure. That was in the confusion matrix. That was the total number of corrected classified predictions. So, again we will see the total number of incorrect predictions, that is having the F10 plus F01. So that was, if again we will see that same confusion matrix. So that is nothing but that is having the F11 plus F10. Again that is having the F11 and F00. So that is the correctly classified labels are there, that is having the F11 plus F00. That is not 100, that is F00, right? So that is correctly classified. That is incorrectly classified is there, that is having the F01 plus F10. So like this we have to calculate the total number of predictions corrected or incorrected. So like this we have to combine those of the two class levels. So although confusion matrix provides the information about the needed to determine how well a classification model it is going to perform, it is also summarizing this information with a single number that would make it more convenient, more handy to compare the performance of different models. So on the basis of this small tables, that is the confusion matrix, on the basis of that we are going to determine this particular model is going to predict accurately or not, how accurate the model is, how the model is good or not. So that is also going to summarize the information in a single line, single value, single number. So that will be more convenient to understand about the particular model. That is also going to on the basis of that we are going to compare some of the other models also. So this can be done using a performance matrix that is having the accuracy. So how we are going to know about how accurate the model is? We are going to use the performance matrix on the basis of these of the few combinations. We are one formula will be there. On the basis of that we are going to measure the accuracy of the model. So here the example is the formula is there for to measure accuracy measure. So accuracy is equal to number of correct predictions divided by the total number of predictions. So that the number of corrected models were F11 plus F00. So that will come in the number of correct predictions, and that will be divided of all the predictions, the total number of predictions. That will be the accuracy of the any particular model, any particular classification model. There will be the error rate. There will also be the error rate. So equivalently the performance of n model will be expressed by the error rate. So which will be given by the following equation, that is having the error rate is equal to number of wrong predictions. So that was having the F11 plus F00 divided by F11 total number of predictions. So right. So like this we have to predict about the error rate and accuracy. Now how decision tree is going to work? So mostly the decision algorithm, the classification algorithm that is going to seek for the model, we are going to seek the model that attain the highest accuracy, equivalently the lower error rate. If higher accuracy will be there, the low error will be there. So that will be applied to the test set, that will be applied for the unknown class labels. So in the decision tree, each leaf node that is assigned to a class level, as we know. So in this figure we can see here the decision tree is for the mammal classification problem. So the non-terminal nodes which includes the node as well as the other internal node. So that will be so that type of nodes we will call as a non-terminal node, that is containing the attribute test conditions to separate records that is having the different characteristics. So on the basis of these of the attribute test condition, we are going to say that is the non-terminal node is there for that. So for example, the root node shown in the figure, in this figure, if we will see the temperature to separate the warm-blooded species, warm-blooded from cold-blooded species. So here, if we will see that body temperature is the root node, that will be divided into the warm blooded and cold blooded. Then there is the one node is there, that is the internal node, that gives birth, that is although classified into the S and no, and that is having the, if gives birth, that is the mammal. If it is not going to give the birth, that is non-mammal. So like this, the classification will occur. That is the classification model. In the right hand side, if we'll see that the other branch, that is the sub branch, that was the internal branch, that is having the non-mammals, and that will not have any that is not having the leaf branches. So that basically that is the leaf branch, that is the leaf node. So like that, the all the species will be divided into the, that is having the mammal, at that who are not having the mammal. So that will be this type of non-mammals terminal nodes will be called as a non-terminal nodes. So how the decision tree is going to work? Since we know all the cold-blooded species vertebrates are non-mammal. So a leaf node labels non-mammals is created into the right side of the root node. So that was the non-terminal node for that. So if the vertebrate is warm-blooded, so a subsequent attribute that is gives birth, that was the internal node for that. That was the sub node for that in the left hand side. So that will be classified, that is going to use to distinguish the mammals from the warm-blooded vertebrates. So which is the mostly having the births, that is not giving the birth into the new species. So like that, we have other class levels will be divided like that. So classifying a test record is straightforward. Basically, once a decision tree has been constructed. So once the decision tree will be constructed, the test record will be classified. The classification from the root node, we apply the test condition to the record and follow the appropriate branch based on to the outcome of the test. So these are the few conditions we are taking care of while we are going to represent a decision tree basically. So we will get another internal node if for which a new test condition will be applied, or we can say to the leaf node. So the class level will be associated with the leaf node, that and after that will be assigned to the record. New record. So for that, if we will see in this example in the right hand side, so in this illustration, the figure traces the path of the decision tree that is used to predict the class level of a flamingo. The path terminates the leaf node. On the leaf node, that is labeled as a non-mammal. So here, if we will see in this example, that is classifying a unlabeled vertebrates. So in this table, if there is unlabeled data is there, right? So here that is the new data. If you will see, the flamingo is there, that is having the warm body temperature, that is not giving the birth to the new species, and the class we don't know. So how we will going to classify these type of unknown class levels? So that will go into the body temperature, warm, that is going to give birth, and then that is not having the mammal. That is not a mammal, but that is the non-mammal. So if the body is warm and that is going to give the birth, and that is non-mammal. So that will be the leaf node of non-mammals. So that a known class level will be classified as a non-mammals. How we are going to build the decision tree? So a decision tree can be constructed from a given set of attributes. So we are having some of the attributes in the table. On the basis of that, we are going to construct the decision tree. So many efficient algorithm will be there, like we are having the iterative decomister ID3, and we are having the C4.5, that is the successor of ID3, and we are having the CART, that is classification and regression tree. So that has been developed to induce a reasonably accurate, eliminate some optimal decision tree. So these are the algorithms to design a new decision tree. So a machine researcher that named as J. Ross Quinlan, that in 1980, that he have developed a decision tree algorithm known as ID3, iterative decomiser. So later he represented C4.5, which was successor of this ID3. So the ID3 and we can say C4.5 adopt a greedy approach, that is having the no backtracking. If we don't have to backtrack, we are going to use the ID3 and C4.5 for the decision tree. So here we are taking the ID3 example, ID3 algorithm for that. So this algorithm start with a training data set. So with the help of the algorithm, we are going to construct the decision tree. So this algorithm start with the training data set with class levels that are partitioned into the smaller subset as the tree that is going to be constructed. So first there will be some steps to do that. So first step is initially there are 3 parameters. There will be 3 parameters. On the basis of these parameters, we are going to divide the branches. Which of the class level is going to be used as a root node, which of the branch is going to be used as an internal node. On the basis of these 3 measures, what are the 3 measures are there? Attribute list, there will be attribute list, attribute selection method, and data partition. So on the basis of these 3, we are going to divide the sum of the class levels. The attribute list describes the attributes of the training set tuples. What are the different attributes are there for each of the class levels? That will be described by these from the training set. In the step 2, the attribute selection method, that is describing the method for selecting the best attribute. So how we are going to know about what is the best attribute is there. So there are some of the techniques are there. There are some of the formula are there to do that. So what we will have when we are having the best attribute. For that, we are using that to discriminate about the other data tuples. So if the best attributes will be there, we will use first and then later then. So the method is used for attribute selection that can be either information gain as well as the Guinea Index. So these are the some formula are there. On the basis of that, we are going to use the best attribute. Step 3. In step 3, the structure of the tree that is having the binary or 9 binary, that is divided by the attribute selection method. In the step 4, in the step 4 of the decision tree construction, when constructing a decision tree, it starts as a single node. So one single node will be there that will representing the tuples. So on the basis of that root node that is having that will call as a root node. On the basis of that, the other branches will be constructed. In the step 5, if the root node tuple represents the different class levels, then it calls an attribute selection method again to split the other branches, to split or partition the other coming tuples. So this step will lead to the formation of branches and decision nodes. So that will be the decision node, that will be the decision particularly node, that root node, that is going to classify some of the branches as well as the decision nodes as well in the decision tree. For the step sets, the splitting method will be there, that is going to determine about the which selected attribute, which best attribute is going to be select to partition the data tuples. So here the best attribute will be there, and then according to that it also determines the branches to be grown from the node, the different nodes according to the what is the outcome is coming from that particular node. So the main motive of the splitting criteria is that the partition of each of the branch of the decision tree, that should represent a same class level, that represent the, if same type of attribute will be there, that is having the same partition. So on that same class level, those of the attributes will be there. So how to split the attributes? Basically we will see. So when suppose first example is there, A, when a portioning attribute is discrete valued, if that is having the discrete value, how it will be carried out. So in this right hand side figure, if that is having the discrete value, that is having the color, that is having the root node, and then that will be divided, that there have been some attribute class levels, same class levels are there. So that is having the colors name, that is having the red, green, yellow, blue. So then that from the root branch, that will be associated as a sub branches in sub branches, that is having the red, green, yellow and blue. So like this the attribute will be splitted, will going to take place as splitting. When the example is for when the portioning attribute is having the continuous value, that is having the continuous value in the nature. So in this figure we can see if there is income, that is having the income that is continuously growing, so that will be classified as a, that is less than and equal to the 20,000, and that is more than the 20,000. Like this, if this type of classes will be there of same class, so that the splitting node will be the income, and then it will be divided into the two of the sub branches. So like this, the splitting criteria is taking place in this decision tree for the different attributes. In the step 7, we will see the ever partitioning steps will be followed recursively, till then iteratively, when from the decision tree for the training dataset tuples will be there. In the step 8, the portioning steps stops only when either all the partitions are made, that all the partitions are made, we have used that, and when the remaining tuples cannot be classified, cannot be partitioned again. So we will not use that those of the tuples again. So we'll stop that particular decision tree there only. So in the step 9, the complexity of the algorithm will be described by n into mod d into log mod d. So where n is the number of attribute in the training data set D, and mod D is the number of tuples. So by this formula, we are going to measure the complexity of the algorithm in the step 9. So how to select the attributes for creating a tree. So we have seen how to construct the tree, how to represent the tree. Now we will see how to measure the attribute from that tuples. So attribute selection measure are also called as a splitting rules to decide how the tuple are going to be split on the different nodes. Different nodes that is having having in the training data set. So the splitting criteria used to that is going to use to best partition of the data set. From the data set, what will be the best attribute that will be classified on that as a splitting node. These are the measures providing a ranking to the attribute for partitioning the training tuple. That is partitioning the what are the training data sets are there. So that is going to be give the some of the ranking, best, then again best, like this. So that will be the chain of that. So the most popular method of selecting the attribute are information gain and Guinea Index. Guinea Index. So we will use the, here first we will take the information gain. So this method is the main method that is going to use to build the decision tree. This information gain that is going to reduce the information, that is going to use the information that is required to classify the different tuples and class labels. It is going to reduce the number of tests, that is going to reduce the number of test sets that are needed to classify the given tuple. The attribute with the highest information that will be selected as a best attribute, right? So like this we have to use that the highest information gain node as a best attribute node. The original information that is needed for classification of a tuple in the dataset D, that is given by this formula ES, entropy of S, that is having the summation of C to I is equal to 1 minus Pi log 2 Pi. So by this formula we are going to use classify a tuple for the dataset D. That is the original information of the different data sets. So where the P was the probability. So there we have used the probability. So the probability that is the having the tuple that is going to belong the C class. Suppose the C class is there, that is going to belong that C class. The information is encoded in bits and therefore the log to the base 2 will be used for that. So for that log will be used in that formula. So ES, that is basically represents the average amount of the information required to find out the class level of dataset D. This information gain is also called as a entropy. That the term is called as an entropy of the data set. So the information required for the exact classification, that was the whole information. But that is if we are going to use the information required for the exact classification after the portioning, that is after the portioning. So the given formula will be there. The E of T x is equal to summation of C subset of x, P, C and EC. So this formula we will use for after the portioning of the different nodes or tuples. So where P of C is the weight of partition, this information represents the information needed to classify the dataset on portioning by the X node. So the information gain is the difference. Now we will count we are going to measure the information. What is the information gain basically is there while the splitting has occurred, and after the splitting, what is the information gain value is there, we will subtract those of the values from each other. So the information gain is the difference between the original and expected information what we have got from these of the formula. So that is required to classify the tuple of dataset D. So gain of T of X is equal to entropy of T, that was the actual entropy, minus entropy of T of X. So now we will get the gain for that particular node, right? So the gain is the reduction of information that is required to knowing the value of X. Basically we are finding out the value of X. The attribute with the highest information gain is chosen as the best. So that which of the we will measure the information the gain for the each of the node, and then we will decide if the higher gain is there, the higher information gain is there, so that will be the best attribute to select for the splitting node. So like this we have to use this information gain to measure the different nodes for to split on the after the root node. So how second is formula is there to as a gain ratio. So information gain will be also that will be calculated by gain ratio, that might sometimes result in portioning useless for classification. So for that we will use the gain ratio. However, the gain ratio splits the training data set into the partitions. So and that is considers the number of tuples of the outcome with R respect to the total tuple. So this example, this formula is basically used to will be used when the portioning of classification will be useless. So this formula will be used. The attribute with the maximum gain ratio will be used as the splitting attribute. So gain ratio formula will be there. Gain ratio A is equal to gain of A divided by split info of D. So on that we will get the gain ratio of that particular node. Third formula is there, Guinea Index. So Guinea Index is conducted, that is calculated for binary variables. So that will be used only for the binary variables. That is going to measure the impurity, basically the impurity in training tuples of dataset D. So the formula will be there for to get the Guinea Index. Guinea is equal to 1 minus summation of I P of I mod T T square. I divided by T of square, whole of the square. So by this formula we are going to get the Guinea Index for that particular attribute. So here the P is the probability that tuple belongs to the class C. The Guinea Index, that is calculated by calculated for the binary split, that in the data set D by attribute A will be given by Guinea of split. Guinea of split is equal to summation of I to I is equal to 1. That is equal to N of I divided by N into Guinea of I. That we have already here, we have already measured in the earlier formula. So that will be, that same value will be here placed. So if we have to find out the Guinea of split, we will use this formula. So where N is the nth partition of the dataset D, and N is nothing but that is the nth partition of the dataset D. So the reduction in impurity will be given by difference of the Guinea Index of the original dataset D and Guinea Index after the splitting of partition by the attribute A. So that Guinea split will be there to use that. So the maximum reduction in impurity or maximum Guinea Index for the selected attribute will be there for the splitting. So like this we will use the Guinea Index. So that was all about the today's topic. Here we have covered the how we are going to build the decision tree. What are the important measures are there? What are the different important terminology are there? How to split the different branches as the sub branches, but that what are the attribute major conditions will be there, what were the formula will be there. So on the basis of that the splitting will be happen. So we have used the information gain for that, we have used the gain ratio as well as the Guinea Index for that. So the best we are using for that the Guinea Index and information gain. So we have covered the decision tree, the important terminology in today's topic. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.